Dear students, good morning. Today we will see about OFDM. So we all know what is OFDM. OFDM is orthogonal frequency division multiplexing. It is a best example for multi-carrier modulation system. So to understand OFDM, you assume that there is a data stream. So you think there is a data stream with r bits per second, and this is sent at a bandwidth of n into fb. So what will be the bit duration? The bit duration will be 1 by r. Now when this is there available, when it is going into OFDM system, this OFDM will split into n parallel data stream. So this n parallel data stream is called as subcarriers. So more number of subcarriers will be there because parallel data, parallel subcarriers, it's called as multi-carrier. Okay. So each subcarrier will occupy a bandwidth of FB. So the data rate will be R by N. So this is the basic concept of OFDM. So it is converting or splitting the serial data into parallel data, and then it will be subcarriers will be added, and then it will be multiplexed and it will be transmitted. Okay, so this is the basic concept. So now this is mixing of subcarriers to the input signal. So while you are doing this, orthogonality is important factor. So that is why it's called as orthogonal frequency division multiplexing. So for orthogonality, so orthogonality is an important feature. So what is orthogonality? The spacing of the F frequency signals are tightly packed. Actually what happens in orthogonality, we are overlapping the signals. Overlap between the signals. Overlap between the signals is permitted. So what will be the signal spacing? Signal spacing will be FB, 2FB, 3FB, etc. The thing is, it should maintain the orthogonality, that is 90 degree apart. When a one signal is having maximum 90 degree, the other should be at 0. So when this is happening, this is maintaining orthogonality, if you make a product of S1 of t into S2 of t, two signals, it will be equal to 0. So this is the concept of orthogonality in OFDM. So from this we can understand that in traditional FDM, there will be no overlapping is permitted, but in OFDM allows overlap, which greatly increases the capacity. So this overlapping of subcarriers, what happens when we are allowing this overlapping? Automatically the capacity increases. So this is how the capacity in an OFDM is increased. So to have a pictorial view of this, what we are going to do, I will draw a diagram so that you will understand. See, assume that so this is one signal. So this is F. This is S of F. So one signal, if it is going like this, what happened to the another signal? It will start like this. It will go, and when this signal is 0, it will go to high, and then it will come down and it will go. Likewise, so when one signal is having 0, when one signal is having 0, the other signal will have the maximum amplitude. So likewise, the orthogonality will be maintained, so that even though if the overlapping is there, the signal will not get interfere each other, or no information will be lost. So this is the concept, or maintaining the orthogonality in an OFDM system. So this is how which is used in all 4G and 5G system. So what is the benefit of OFDM? If you are seeing the advantage of OFDM, the frequency selective fading will affect some subcarriers which can be removed by forward error correction coding. FEC will remove this frequency selective fading which may occur in the subcarriers. So this when you are using this OFDM, the intersymbol interference may occur if you are not maintaining the orthogonality. If you are maintaining the orthogonality, the intersymbol interference will be avoided. Suppose in some cases if it is happening, then this can be overcome by the help of cyclic prefix, which is nothing but adding the tail part of this information to the starting part, which lead to maintain the orthogonality, and also the information will be added to this. So adding cyclic prefix and also maintaining the orthogonality will give the improved capacity, improved or increased capacity of a system. So this is the concept behind the OFDM. Students, hope you understood. Thank you.